Now, to get a more better context to it, we define another class here called cat, just like the dog uh, class in inheritance. If you look at the third point here called polymorphism, it inherited, it uses animal object as a parameter, uses constructor class to inherit the name and species attributes of the animal class. It defines a unique attribute called color, and then it defines bark method for cat as cat don't bark. Now that we have the context of what cat function is, now you'll understand we have two functions that are using animal object as a parameter and inheriting using the constructor class the attributes of the animal object. What this means in context is that this depicts behavior of polymorphism, which comes back to the definition we mentioned, that polymorphism allows objects of different classes. Now, these are different objects, cat and dog, they're different objects, but we can treat them as an object of a common superclass because both of them are inheriting values and attributes from the animal object. And that is basically what polymorphism means. It isn't very complex. A lot of people would get confused and try to think that it's something more complicated, but it isn't. It's very simple. It's very simply, polymorphism is just common objects that have a common super object. In this case, cat and dog have a common animal super object that they're inheriting from. The last aspect or concept of the object-oriented programming is called abstraction. Abstraction is basically hiding complex implementation details and showing only essential features of an object. What this means is that people don't need to understand exactly what's going on within an object. They just need to understand what the output and the input of those objects are, right? So what does this mean in a more realistic scenario, or a more more rational scenario, practical scenario, when we're talking about object-oriented programming paradigm? It means when you write an object, it can work independent of any code base and give the same response. And if it's integrated in the code base, it gives the same response, right? That's one of the important features of object-oriented programming. You can break down code into different objects and then integrate that quite easily. And you can even, disassociate that code from each other and it still works. That's one of the, very important, powerful aspects of object-oriented programming. And with that, I think those are the four main aspects of what object-oriented programming is. Important part here is to make sure that, you go over these concepts and understand them in, uh, very deeply, because they will all four of them are basically uh, mental models you need when you're going to build your programs using object-oriented programming. Now this portion here is just how we run the code. We first define two variables called Tommy and Whiskers, which Tommy is defined as a dog object, which has we're defining a name and the breed, and cat Whiskers is defined as a cat object where we're defining a name and a color. Color and breed are in unique aspects of these subclasses. Uh, First, we demonstrate encapsulation using Tommy.describe, which is a function we defined in the animal subclass, where we could simply say that this is the name and this is the this is the species. That simple as that. Second, we demonstrate inheritance and polymorphism, where we demonstrate inheritance and polymorphism in the second portion right here. For an animal in Tommy and Whiskers, those are the two cat and dog sub-objects we defined. We print animal.describe, that is the method in the animal object that we defined above. And then we use animal.bark to identify exactly what sort of sound one a particular animal would make. Now, how does this demonstrate inheritance and polymorphism? A, inheritance is depicted because we're using animal-based methods. We can use animal-based method here, and we can also use the subclass class methods as well here. So let's run this piece of code and see if it works as intended. So we see here, according to our tests, Tommy is a dog. That's when we call on the tommy.describe. That works fine. It shows encapsulation of data. And in the second portion, it defines Tommy as a dog, woof woof. It demonstrates inheritance and polymorphism. And Whiskers is a cat, cats don't bark. That also demonstrates inheritance and polymorphism for the cat object, and the above for the dog object. That is basically all there is to object-oriented programming. George, would you like to add anything in the end?
No, I mean, pretty much you went over it quite succinctly. Good job. And essentially, don't have anything else to say. Just if you want more content like this, or if you have any ideas for content, just put a comment in the comment section, and we'll try to make a video that's prescribed specifically for you. That's all I have, Mohammed.
All right. So if you want to see more videos like this, just give us a like and subscribe our page. And if you have any specific topic or concept that you don't understand and you want us to make a video on that, please let us know in the comments section, and we'll see you in our next video.